Okay, so here's a bonus video. I'm going to go through kind of maybe the hardest problem you might see in the book or on a worksheet or something like that. We're going to try to break it down into more simplified steps for you on the quiz. But if you want to know how to do a problem like this, this is your approach, okay? So we have 5.0 grams of iron sulfide, 3.9 grams of oxygen, and they're reacting with each other. When we do that reaction, we get 3.7 grams of SO2 produced. What is the percent yield, okay? Well, if you guys remember, percent yield is actual, let me change that to an A, actual yield over theoretical yield times 100. Well, which one of those pieces do I already know? I know the actual yield, okay? So my actual yield is 3.7 grams of SO2. It tells me that's how many are produced, okay? This is the piece that I don't know yet. I need to figure that out before I can find my percent yield. And this is going to be a limiting reactants problem. I have 5 grams of iron sulfide and 3.9 grams of oxygen. How many grams should I be able to make of SO2? Okay, so here we go. 5.0 grams of FeS2, 3.9 grams of oxygen, and I'm going to go all the way to grams of SO2 for each of these. So all the way across your molar map. So 1 mole of FeS2 is 120.0 grams of FeS2. So grams go away. Next step on the molar map is the mole ratio. 4 moles of that for every 8 moles of this. So 4 moles FeS2 for every 8 moles of SO2. Because remember, we're trying to figure out how much SO2 we should be able to make. And then the last step, 1 mole of SO2 has a molar mass of 64.1 grams. Moles cancel, we get to grams, okay? Setting this one up the same way, 32.0 grams of O2 is 1 mole of O2. Mole ratio here, again, we're trying to find SO2. So 11 moles of oxygen for every 8 moles of SO2. Oxygen on the bottom to cancel. 8 moles of SO2 on the top because that's our destination. And then the last step will be the same. 1 mole of SO2 for every 64.1 grams of SO2. Okay, I'm going to get 2 answers to these. They're both going to have 2 sig figs because of my starting values there. Okay, so this one is 5.3 grams of SO2 should be produced if this much FeS2 reacts. All right, the next one. This one's going to give me 5.7 grams of SO2 if all 3.9 grams of oxygen reacts. Well, I can't make 5.7 grams if I run out of iron sulfide when I hit 5.3 grams, okay? So my theoretical yield is right here. This is how much I should be able to make, and that at that point we run out of FeS2. So that's my theoretical yield. That's going to go right there. Now I can find my percent yield. So percent yield equals 3.7, my actual grams, over 5.7, my theoretical, not 5.7, 5.3, sorry, my theoretical, and then times 100. So 3.7 divided by 5.3 times 100, and we're going to get something that rounds to 70%. And in order to make that have 2 sig figs, I need to put a little dot to give me that, woohoo, that 0 is significant, okay? That draws your attention to the fact that that 0 counts. So 2 sig figs, that's my answer. And again, that's kind of just the bonus video to help you with one of the more complicated problems you might see.